Hello, this is Miss Brizantine. For our next virtual lab, we're going to do a motion lab. And here I have a simulation that we're going to use because I know some of you might not have this equipment at your school. Um, what we have here, and this website is posted below in the instructions, but on this website they have if you subscribe to the site, and we're not going to, they have a variety of simulations that you can go through. Okay. What we're going to use is the top up here, which is a preview that we have a DLC subscribed to before, but the preview will help us for today. So all of this is interactive. Over here on the right is the graphing area, and you can make changes to the graphs, but the part of the graphing area we're going to use most is looking at the actual graph and the clear line button. To the left of that we have it's a motion track. It's basically it's just a ramp for this cart to go through, to go on. And the interesting thing about this ramp is that you can move and change the angle. So it's basically on a fulcrum, it's on a pivot point here. So if you take your mouse when you are near the end of when you're near one of the ends, if you notice my mouse goes from a pointer to a hand when you're near the end. So when your pointer is a hand, you can actually click and change the incline of the ramp, allowing the cart to slide down the ramp. Okay, so let's leave it here at an angle for zero for a moment. Okay, right now the wheels are chosen. There is also a friction pad, which would not allow the cart to travel as quickly. So let's look at that. So with the friction pad, you have to have the ramp at a fairly high angle before the cart's going to move. It's basically on a rougher surface. We'll talk about friction later. But we just want to notice that if you want to use the friction pad, the angle you choose for the ramp is going to need to be higher to allow it to slide down. So what we want to do, and you may notice the screen thing out here moving with the ramp, right? That is going to be our meter stick and our stopwatch. The motion detector, all it wants, records the time, measures the time from when you turn the motion detector on, and this little window is pointing at the cart. It's basically like a laser or a radar detector, and it can tell how far away the cart is as time goes on. So it will actually graph. That data is what is used to graph the position versus time graph on the right. So let's see. I have this set at an angle of -8, and it's reading the angle from the down vertical, I believe. Let's see. Okay. The sign on the angle is not our concern right now. If you want the cart to speed up, you'll want a negative angle. And that's what we want for this one. Okay, so we want the cart to speed up as it travels away from the motion detector. So choose some negative angle. Realize the information will be a little harder to read. If you have a higher angle, right, things are going to travel faster. Okay, so choose ideally a negative angle between 0 and 10. Turn the brake on so the cart doesn't move until you're ready for it, and set it near the motion detector. Right now the sensor is off. There's no graphing happening, and it says sensor off right here. Okay. If you turn the sensor on and disengage the brake, if it's not moving, you can just turn on the wheels. All we want is this cart to move. If you notice, we actually got a graph over here. Once I turned the sensor on, you started getting data. When the cart started to move, you see the position change as time goes on. And once the cart hit the end over here, you see this little, it stops changing position. It actually bounced backwards a little bit, and then it stopped at the end of the cart, the end of the ramp. So you can see the position versus time as the cart goes on. Okay, what you want to do is get this as clean as possible. Try to get your timing so that this long straight line is as small as you can. And turn off the sensor as close to the end as possible. Now we can delete this data later, but you want to gather a good set of data.